have on the Parrot Tailings?
Yes, we
Joe,
do.
Sarah? We do have
I
some.
couldn't really see on the slide.
Yeah,
We got a few in there.
There's a few in there.
Yeah, you see me asking these folks because
Sure.
they know way more than I'll ever know about this.
Could you explain hydraulic conductivity in those terms?
Well, it'd probably be better for a hydrogeologist to answer the question, but porosity is basically how much void space there is in a unit that basically says how much water you can have in a unit. Hydraulic conductivity is the ability for that water to move through it. So, in other words, you know, like I'm trying to come up with a good comparison, but basically that's it. Just because it's porous doesn't mean stuff necessarily moves through it easily. You know, some clays have a fair amount of porosity, but it doesn't move that well through it because you don't have a lot of interconnected pathways down the part.
Yeah, I understand.
Can you demonstrate capture at all?
Demonstrate.
The logic of the argument seems to be that we're meeting most of the time surface water standards as it gets to Silverbow Creek. Therefore, we've prevented it with the subdrain or the design of that system. But those two things don't necessarily follow each other. And we've also characterized middle alluvial aquifer and a deep alluvial aquifer directly under the Parrot Tailings that are demonstrably toxic and serve as a bigger threat to immediate human health and well-being than the Virgin Pit does because it's contained. So it seems like a logical fallacy to me in this gradient. That's the first time I've seen that information presented. Oh, it's coming through there faster, but it's not moving vertically.
Well, I'm just saying it doesn't necessarily. But let me go back and answer your question. Demonstrating capture, that is a tough. It's a tough question, and it's part of the reason that we have a lot of the differences of opinion we do, because you know I don't think you could ever demonstrate complete capture, and our goal wasn't necessarily to capture every molecule of contaminated groundwater out there, because it's simply not possible. You couldn't do it, and so really what you're looking at is you look at both. You look at gradients to see is water flowing towards the capture system. And then you look at your monitoring network, both closer to the system and out at the boundaries of where your existing contaminated groundwater plume is. And two or three things that we're trying to accomplish. One, we don't want the contaminated groundwater plume expanding. And so that's one of the things we look at. We don't want concentrations increasing down gradient of the capture systems. That would indicate that something's getting through, around, over, under the capture system. If you have, and so you're looking at, and that becomes difficult because then you're looking at statistical analyses of what constitutes an increasing or decreasing trend, and you have to monitor for long term to determine that. So to look at capture and to demonstrate capture, you have to look at multiple lines of evidence. You have to look at a number of different things. The one thing that we really are trying to protect is we're trying to improve, a lot of it is trying to protect surface water quality. Currently, we're trying to address that contaminated groundwater or exposure to that contaminated groundwater through, well, if people are in the municipal water supply system, they're not exposed to it. If, you know, and trying to find people, anybody that might have a well into it, trying to make sure that we take care of that, because we don't think you're going to get there to clean up all that contaminated groundwater within a reasonable time frame. So we're going to have to be pumping and treating to keep the size of the plume from expanding, to make sure that contamination isn't continuing to trying to reduce what's flowing offsite. Obviously, at the downstream end of Silverbow Creek, you've got contaminated groundwater, and no, it's difficult to address it because it's that boundary between operable unit 1 or operable unit priority soils operable unit and streamside tailings it's just a boundary that was drawn, and there was contamination there before and after. So really, what we're looking at that end is trying to see our groundwater concentrations increasing or decreasing. So did that kind of go?
Yeah, you spoke to the complexity of trying to
address that capture.
To speak to capture, but given the new information that we have, that's based on the that impracticability, the kind of announcement of impracticability, does that still follow when we now know that it will cost less than half of what we said it was in the water, and the source of contamination is known and seems to be moving through in more complex ways, and has been traced as far as Caw Avenue?
Well, it's a good question, and that's the question we're still trying to answer. The hydraulic conductivity data by itself doesn't answer that question. I understand the new cost data that you guys had, the council had put together, you know, in looking at some of that. A lot of the differences in the cost information there is based on how much material you're going to remove. If you're going to remove less of it, you're going to deal with less cost, and so the argument would be that there's, at least for EPA, in order for us to, you know, balance that need for long-term groundwater treatment, well, it's not even that. I mean, really, it goes to, can you clean up that aquifer within a reasonable amount of time? And the modeling that we do, there's a lot of uncertainty in the modeling. It's only as good as the assumptions that go into it. And that's where one data point has shown that the hydraulic conductivity is quite a bit higher. But as I pointed out, there's a lot of other parameters that go into that analysis, and that's why we're continuing to collect data. I'll kind of go back. Let me kind of go around to where we are. We were trying to revise the conceptual site model for groundwater and surface water, where groundwater is contaminated, where it's going, and we're just going round and round internally with a lot of very good people with a lot of experience and widely differing opinions over what exactly is going on. And the reason that we couldn't decide that is because models are just models. You know, you try and put in good data and you use them as something that helps you make a decision. Once you make that decision, what you do then is you try and use these other lines of evidence, this other data, to show whether or not that model is valid. Now, the hydraulic conductivity calls into question, you know, the change there calls into question the assumption that went into the model. But then you have to start, then we also look at the groundwater monitoring data and the surface water monitoring data and trying to find out, you know, does that make a difference? And right now we're not seeing it yet. But as was pointed out to me by the state fairly recently, a lot of these wells we haven't been monitoring for that long a time, and we're gonna need a little longer time frame to develop a really good history on those wells, so we can see whether or not we're dealing with normal fluctuations or whether there are actual trends increasing or decreasing stable. So,
is it your position then, or the position of the EPA, that if the Parrot Tailings were removed, it would still take 100 years to flush the system?
Well, I don't know if it would take exactly 100, but it's going to take a while. We don't see it. We don't see a difference, and part of what you're looking at too, when you look at that cost difference, if you think, okay, in 100 years we might get below groundwater standards. For us, you've got that groundwater pump and treat for 100 years. Those cost savings out 100 years in terms of today's dollars, when you're looking at present worth, you know, it's not as big a cost difference in today's dollars when you do that present worth analysis. So, but this really isn't. From my perspective, it's not really about the cost. It's really about how effective, how much difference is that going to make to the remedy, you know, and the need to continue to pump and treat, how quickly you're going to meet those standards. And we still think it's going to take quite a while, regardless of that change in the hydraulic conductivity. So.
And I guess my question kind of goes off yours, Chad. Has the new data that you've collected with the aquifer test and the changes in conductivity, has that adjusted that 100-year mark at all?
You know, we haven't gone through and rerun the models at this point. What we're currently looking at today, you know, is basically we're trying to factor those data into design of the systems that we decided to put in place. Because basically for that decision, for us to change that decision, one of the things we would have to look at is protectiveness as well. We would have to look at indications that for some reason, if our revenue wasn't protective, then we would really need to go. That's the point at which we would need to change that decision. You know, or I mean, I suppose if something said, no, you can clean this up in 10 years, you know, that might be something we'd be interested in. We'd be interested At this point, that data point, and you got to remember, that's one zone. That's the hydraulic conductivity of one zone from a limited pump. We had 6 pumping tests or 6 data points previously that we used to come up with some averages for hydraulic conductivity.
But it is the most contaminated zone and the most conductive zone, which indicates it's probably the preferential flow.
Well, actually, I think the most contaminated zone at the current time is in the clay. We've got some clays that there's a lot bound up in there. So
That are filtering what's going on. And is the clay below or above the middle aquifer?
Joe, Sarah, you guys know? Where's that clay situated? It's above the middle aquifer, isn't it?
I believe it sits in between the upper and the middle, but I'm not actually sure. And what we know about the clay is not from wells, but from the drilling that the Bureau's done. So I really couldn't answer the question.
Well, I think the Bureau's also, Bureau's going to be doing some percolation tests as well, or some leachability. Are they going to be doing some additional leachability?
Not that I know.
Oh, okay, maybe I was misinformed on that.
They did some earlier that indicated much quicker plant. I think 3-4 volumes is what they looked at.
Time frames, yeah. And it was a single sample, and I think they're going to go back and as
And
far as my understanding is they're going to redo that based on some additional ones. Right?
And I think that clay layer is between the upper and middle.
Is it?
Right?
We can find that out.
I do.
Right.
It's
I'm
definitely
sure it
above
is.
the
We
middle.
talked
get back
about
to
that
that.
the other day.
How many wells do you have in that area and how frequently are they being monitored? And
Just in the area of the Parrot Tailings?
Mm-hmm.
And if I may ask a secondary to her, let's go over all of the Monacan wells. I've heard from EPA, DEQ, and BMG that although there's a lot of wells, there's been disparate scheduling on testing. They haven't been tested when they should have been tested. The data, so then they say, well, case around, we can't make a good statistical model from this because we didn't take tests when we should have, or there's not data to support anything. So then we're back to when we need to go out and start testing. There's sort of this so sorry to tag along with your
No,
question, but
that was.
Well, I mean,
not
I-
just the Parrot, but everything that's going to drive you on monitoring your decision. Is there an actual
Is there a set
schedule?
frequency?
There is now, yeah.
There is now,
and-
since.
Well, there
Since
has
2006.
been. Well, yeah, I mean, since 2006 and since the monitoring plan, there was an interim monitoring plan that was developed post-regular decision. Prior to that, a lot of the groundwater monitoring, the wells that were installed were to evaluate specific purposes, either a particular removal or a particular area, and really what's happened is over time the groundwater monitoring well network has expanded. We've added additional wells. Yeah, there is not a schedule on every well since it was implemented, because a lot of times you install them for a certain purpose, you go do the sampling, you use that for, and so where we're trying to get to is this point of which, once we start implementing the remedy, once we get the remedy implemented, then you've got groundwater monitoring and surface water monitoring that's targeted at evaluating the performance and effectiveness of the remedy. And so those are the wells that you start to develop a long time history on. Some of the wells that you may have sampled back in the 1990s may no longer be relevant just because you may have installed some collection system immediately down gradient of it. You don't need that information anymore. And new wells have kind of been put in place to really evaluate the components of the remedy and the effectiveness of the remedy. And so that's why you don't have a history on a continuous history on every well that's out there. There are a lot of different processes that went in place. I don't know how many we have right in the area of.
In the Parrot Tailings, we have 2.
2 in the tailings.
In the tailings.
But
Yes.
then we've got some
And then
some in areas. Oops, sorry. I can't quite read that. It might be on a different slide. We can get you that information about the wells that are in and around.
And what's the frequency that you have set now?
What are we doing for
Mike, go ahead.
quality?
Frequency
Twice
for
a year.
water quality?
Yeah.
twice a year.
Twice a year for water quality, quarterly, or for water levels, or
Monthly for water
monthly for
levels.
water levels?
Almost all of them have sensors in them and measure it every hour.
Continuous.
15 minutes.
but semi-annual twice a
That way
year.
for a year, water quality.
Yeah. And that's actually all in the, what do we call the plan? The revised interim,
Groundwater
Groundwater
monitoring
monitoring plan.
plan.
and which is available. Or it's,
Annex E of the UAO.
Yeah, it's part of the UAO.
Or the